Module 3, SQL Server Health Check. A basic health check in SQL Server can be done by inspecting the overall aspects of the SQL instance, such as database status, critical errors, the SQL Errorlog, or active connections. It can go even further by combining it with operating system checks, such as CPU or memory utilization, active jobs in SQL agent, blockings, top running queries, and more, just to name a few. For now, we will limit to some common situations such as service status. So a basic health check can be done through the graphical interface or Transact SQL, and I always recommend Transact SQL over the display-only checks because they can generate quick evidences, and these can be valuable for critical situations where the DBA must act promptly. Common statement from the customer or even end users is that the SQL database is down or the whole SQL Server is down. Sometimes we need to be aware that the customer or end users may not know the difference between a SQL instance, a user database, so if their applications throw a generic error, they will claim the SQL is down, and that's okay. It's the DBA duty to determine what actually is down and act on it accordingly. And here I am just reinforcing what I stated in the previous slide. Do not rely on the interface as it can be tricky sometimes. And there are a variety of techniques to be used, and we will look into each one of them in the practice at the end of this module. The database console commands are very useful for troubleshooting purposes and health checking as well. The DBCC checkDB is one of the essential ones that should not be missed, because its output will indicate if there is corruption on your database, and it's considered a best practice to run it before starting a backup and after a database is reinitialized or restored. One point of attention, however, is that checkDB can take a very long time to finish for very large databases because it generates a snapshot during the execution, and the process could be aborted if the database is running out of internal space. So if you do not want to run DBCC checkDB for the whole database, there are some variations such as the check table, where you can check the consistency only for a specific table inside your database. There are situations during a health check where the DBA will have to inspect which users or processes are connected to a SQL instance to narrow down the search for the cause of an ongoing issue. There are some different commands for this, from the oldest one that produce raw data such as spwho or the sys.sysprocesses table, and we have the refined dynamic management views that are useful for troubleshooting with a more deeper level of details, such as checking reads and write per database files, index usage, average CPU usage of each query. I'll show you some example on these commands at the end of the module. The event viewer is a classic Windows Server log where critical errors are recorded, such as hardware failures, memory alerts, or services stopped and started. For most situations, they are useful at the starting point of an investigation when performing health check on a Windows level. The SQL Server Errorlog stores a variety of data from informational messages to critical errors, mostly related to the product and physical infrastructure, such as database offline, corruption, database space issues, transaction log full, and others. And it can be customized to display further errors, such as deadlock graphs or application-specific messages. Inspecting the SQL Server properties is also essential to know the behavior of a SQL Server instance, especially if there are recent changes to it. Common settings that are more frequently modified are parallelism, maximum server memory, backup compression, and audit level, just to name a few. There are much more, and this can also be browsed using spconfigure, a system-level store procedure. A blocked process happens when a server process ID, or SPID, attempts to perform an operation and is blocked by one or more SPIDs. And a deadlock event is when mutual blocking occurs, so SQL Server chooses one of these SPIDs to terminate it automatically. Let's take a look now on a graphical representation. So here we have a SPID updating a table named client, and at the same time in a parallel transaction a different SPID is updating the store table. So at this moment there is no relation between these two transactions. But now the first bid will try to update the store table and it will be blocked. And finally, the second transaction will try to update the client and it will be blocked as well. But since it is a mutual blocking situation and this bid was the one who caused the mutual blocking, it will be chosen as the deadlock victim by SQL Server, which will terminate the process automatically. And here are some examples on locks on SQL Server. There's a shared lock used in read operations such as select statement, exclusive logs for when a transaction is modifying data, the update lock, which is sort of a temporary lock that converts itself to exclusive when the row to be updated is found, and the intent lock. There are many others, and a good source to look into them all is the SQL Server Books Online. Now in this demo, I will show you a variety of commands that can be used during a SQL Server health check situation. So let's get things started right away. So these are the queries that are going to be used on this exercise. I'm starting with number 1, basic info. This is a built-in function named server properties where we can inspect SQL Server data. I'm going to execute it. There we go. So we have the Windows Server name, the edition of my SQL Server, in this case Enterprise Edition 64-bit. The SQL instance name, in this case I'm using SQL Training. This is called a named instance. So I defined a specific name to my SQL Server during the installation. If I don't specify any name, the standard name, it's MS SQL Server. So this is a named instance. Here it's showing me that it's not clustered, so the value is 0. It's showing me that SQL Server 2012 because the build it's 11.0, and the current service pack level or product level, in this case service pack 1. So this is a good script for you to run when you are getting to know a SQL Server instance that you started to support, or if you're logged in an environment for the first time. Now the second one, healthcheck.sql, it provides more information. As you can see, the piece of code is larger, it has some condition checks, and this one will print the information in a more friendly format when I execute it. So we have the status check report, SQL instance name, when the SQL Server was last restarted in the server time zone. It says is the standalone SQL Server, calculates the SQL Server version based on build level. In this case says me it's 2012, it's correct. Service pack level, the edition, again the Windows Server name, and it also checks the database status. System and user says that always online. So if we had a SQL Server restart, for example, and whatever a database is not coming online, this check can pick it up and show it here. How many user databases we have, and the status of the SQL Server agent as well. So we have more information here, and it's useful because it's in a text format and you can use it to show to your client or to save it as the evidence on an incident record. Moving to the next script, get uptime. I'm going to run this so you can see SQL Server it's online for 0 days, 0 hours, and only 14 minutes because I just started it a few minutes back. So you can ask yourself why this is relevant, why such piece of code it's relevant to a DBA. So imagine yourself in a situation you are on a critical incident with your client in a conference call, and you as the DBA may be asked, hey, for how long the SQL Server is running? For a week, 2 days, 1 month? With this code you can access this information right away. So sometimes even the smallest piece of code or simplicity can be very effective. So you can have this information right away, and it can help you to isolate the possible causes of a problem, because you can say, hey, this SQL Server it's online for like 2 months or 1 month, some weeks, whatever. So you can start to isolate the problem cause by having this kind of information at your hand in a very fast manner. The next one, it's hardware info. This is a script from Glenn Barry from SQLskills.com, and it will show me basic hardware information. Just like the first one, this is good for you are getting to know a SQL Server instance, or maybe perform a capacity baseline. So you need to know physical memory, CPU count, processor information, it's all here. So it's another information that you can retrieve right away using Transact SQL. Script number 5, I name it here as complete status because it has even more information than the other one I just showed. So let me hit execute, and it's, as you can see, it's similar to the other one, and it has just a little bit more details. So check it data, the host name, SQL Server edition, if it's cluster, product level, last startup, it's calculate the uptimes, the version of SQL Server, if reporting services installed, the current port that it's listening, where are the binary paths installed. So let me show you, it shows me here the system, the log paths. Let me expand this to show you. There it is. See if we can have this basic information right away. And the service properties like the service account, the startup mode for the SQL engine, and the SQL Server agent. You can get the service account here. In this case, I'm using Nick as my user to run SQL Server and both agent. Okay. Now let me show you spconfigure. This command is useful to check the properties on SQL Server. So if I right click here to the interface and click properties, I'll have general, memory, processor, a lot of things here I can see or even change. But instead I'm going to show you by command first. So let me do an spconfigure. As you can see, 69 rows affected. Sometimes if you run this command without doing this first, show advanced options, it will display only a limited amount of information. So I have executed this before, show advanced options equal to 1, which is I'm turning on this option. So the spconfigure show me all available data that I can modify here. I can change thresholds, values. So let me adjust the memory to 512 megabytes. I'm running spconfigure, name max server memory in megabytes, and I'm putting the value 512. We configure it, override, and go. And now change it from 4 gigabytes to a half gigabyte. If I go here, properties, memory, there we go. It's already updated in the properties. So that's just an example of settings you can change using spconfigure. I can also change backup compression using this command. There you go. Actually, I'm going to change it to 1 because it was not enabled. So let me show you here first. Properties, database settings. You can see compress backup. It's not enabled. This was a feature that was started in SQL Server 2008. Let me close this. So I'm going to enable backup compression. And let me inspect how it is now. So run value 1 means it's enabled. And if I go back here again, properties, database settings, as you can see, it's marked the checkbox. The next one is the DBCC commands. So here I'm validating the consistency for the MSDB, which is a system database. So here's the command string. It's very simple. Execute. You see that the output is very large, but don't worry, what we need, it's on the very bottom. SQL Server would check all the objects on this database. You see a lot of sys. Name and tables because those are system databases, and at the very bottom you can find what we need. So checkDB found 0 allocation errors and 0 consistency errors on the database. So here's one example where it worked without any problems. So let's take a look now at how is the output of the command when a database has some sort of problem. This one, you can already see the exclamation sign at the bottom, query completed with errors. So let me scroll down here a little bit, and these are the errors occurred, table errors. And if we go to the bottom, SQL Server says CheckDB found 0 allocation errors and 4 consistency errors in the stock database. And it already recommends what it thinks that it will fix the problem. So it's recommending a repair command with allow data loss. So DBCC CheckDB, the database name with repair with allow data loss, it thinks that it could help to solve the problem. So depending on which level of problem it finds on the output of the CheckDB, it will recommend you an action. Sometimes, depending on the level of corruption that it finds, it will even tell you to restart the database from a full backup or do a repair. So another type of variation for the command is the DBCC check table, and I'm including on this string all the error messages should they occur. Using the wrong database, let me switch to MSDB, there we go. No problems found. He just returned the check. And this is another classic command. I wanted to show you the SQL perf log space, another DBCC category command. It will check all the database on MySQL server, the transaction log size, and how much percent of this log is currently used. We're going to talk a little bit more about the transaction log structure in the next module, database structures. Now to the DMVs. The dynamic management views were introduced back in SQL Server 2005, and they are very powerful as you can check a lot of information, such as I wrote here: operating system info, performance data, indexing. You can pick up information from active users, active sessions, and queries. So you can mix up different DMVs in the same piece of code, so you can retrieve information from real time on what's happening with SQL Server. And before showing them, I'm going to present some old commands, some what I call legacy commands, that they still work, but they do not produce the refined data that we can check with DMVs. So let me select everything from this table, the sysprocesses one, and as you can see, it's not very filtered, so you can see a lot of columns, such as what the process is actually doing, the username, and there's a lot of data here that's not readable unless it's formatted. We can do this with DMVs, hostname, physical I/O, how much CPU each process is consuming. And in SQL Server, every SPID, every session server process ID that is higher than 50 means a user process. So here I'm filtering this information but still using the raw data from the table, like so. And there's the SP who true, who show me basically the same information but with some filters. You can see there are less columns than before. The SPID, status, the login, hostname, if it's blocked or not, database that he's using, the command. As I said, these guys here until the 50 on the SPID number, they are system processes, and these others starting from 51 to 62, they are user data. Now let's take a look at some DMVs in practice. So this code would get a count of SQL connections by IP address and host name. Since this is a local lab, there won't be much connections, but just so you can have an idea on how the output is. So I'm filtering the DMV sysdm exec sessions with sysdm exec connections, and I'm putting some filters. So you can see the host name, it's my computer, how many connections per user, what is the program that is using to connect. So we have Management Studio, an open query, and a SQL agent that is active. I'm going to inspect now some running queries by using DMV exec requests, exec connections, and sessions. Let me execute it. Okay, there's only one running. And this one would track uncommitted transactions. This is from Paul Render from SQLskills.com. There's none, but let me run a workload here. Check that it show you. Okay, now we should be able to see something. There it is. Two transactions, user transactions, 56 and 57. The database that they're running, and these are not yet committed. So we are able to see this. They're doing inserts on user databases. We're only able to see them by combining data from DMVs. DM transaction, DM database transactions, exec connections, exec requests. So there's a lot of them available. You can see in the documentation from books online the whole set of them. So we just wanted to show you how powerful are the DMVs if we apply the right filters to them. You can also inspect backup information using them. So let me process a backup on the archive database. I'm going to run this command to start a backup, and here we have the backup duration using DM exec requests. I'm putting a filter on the command that includes backup, and I will be able to see how many minutes are left for the command to complete. So here it is, session number 55. It's running a backup database on the archive data, and around 7 minutes to finish. The next topic to look now is the SQL Server Errorlog. The Errorlog is nothing more than a text file that you can open with Word, WordPad, Notepad, whatever text reader you want to, and the physical location of the file we can check with this command using the server property built-in function. So it's in the standard path here: program files, SQL Server, the SQL instance name, and on the log folder. We can read it through Management Studio if the Errorlog is not very large in this case, because imagine a production server where an Errorlog is huge. I have seen a case where it had like 250 gigabytes because an application was producing so many messages in a loop that the log was growing until it reached the maximum disk size. So it was impossible to execute this command and read it using SQL Server. It would stop my session. So make sure you know the size of the physical size of the Errorlog before running this string. Now here's a sample on how it looks like. In this case, these were the events logged when the SQL Server was starting. As you can see here, startup parameter, the service account, the authentication mode. These are evidences that the SQL Server is starting. How many gigabytes of RAM the operating system has, and many other technical data. I'm going to close this Object Explorer so you can see more of it. There it is. Starting the databases, many messages. The check DB that I did before, it's here. The login succeeded. Remember that option we configure on the properties for the auditing. Login succeeded, and a lot of other messages. DBCC, check DB, whatever. So let me open again the Object Explorer. This next command will change the amount of Errorlog files that are retained from 6, which is the default value, to 99. According to the security policy, depending on the client you work with, you are required to change this number to the maximum amount, which is 99. And it's even considered a good practice because as much Errorlogs you have, the more Errorlogs you have, it's better for you to have evidences on what happened to your SQL Server. So if I expand management, go to right click on Errorlog configure, you can see that it's set to 6, and I can change using 99 here or running this command. So the more logs you have, it's better for troubleshooting. We can recycle the Errorlog should it get too big. Maybe you want to archive your Errorlogs, you want to delete old and unneeded files. You can recycle, so SQL Server will produce a new file. You just run this command sp cycle underline errorlog, and if you read it again, you'll see that it's much smaller now than it was before. And you need to look for this message to know that it was recycled. So the error log has been reinitialized, and there you have a small error log. We can also use the SP error log store procedure to look for errors inside it. So let me look here for DBCC on the error log number 1, which is the previous error log I just recycled, and let it see if it finds anything. There it is. It found the BCC strings using this piece of code. That was the evidence. There it is. So in the error log, what you mostly see are physical related errors related to the database infrastructure. So database full transaction log errors, database brought online, database brought offline, users connected, users disconnecting. Let me give you another sample here. If I go here to properties, security, you can see the auditing. It's getting both failed and successful logins. So let me do a test here. I'm going to try to connect to SQL Server using a login that doesn't exist. Let me put Heisenberg2 and whatever password. Hit connect. Show me an error. I'm going to try it a few more times. Then hit cancel, and let's look at the error log again. Login succeeded, and then there is the login failed for Heisenberg2. Could not find a login matching the name provided. So that option is useful for us to have in the error log the evidences that someone tried to access the SQL Server. So you can track unauthorized access, or you can do problem determination using this information. Now the last step is the blocked process one. I'm going to close the error log in the previous DMVs, and here it is. To start this one, I'm going to create two tables. The first one is host country on TempDB. These are the host countries for the previous soccer World Cups. There we go. And the other table will be the finalists, two teams for each year, creating the table and inserting data. And this is where I'm going to run the block simulation. I'm going to close this for now, open the blocked process left and then the right. Let me split the screen. Vertical tab group, there it is. So what I'm doing is I'll be opening two explicit transactions using the begin trend. So starting a transaction here and this. Now the first transactions will update the host country and set name to Brazil, where the host here is 2014 because Brazil was the host of the last World Cup. And I'm correcting this information in the table. There is one row affected, while the second transaction is going to update the finalist table and set the second team as Spain, which is one of the finalists in 2010. There it is. So far, no relation between the two transactions. But now, the first transaction is doing the same thing as I did here in the second. So he's also trying to update Spain. And note that my screen got blank here. So this guy here is blocked. So speed number 52 is blocked by 55. As you can see, the query is marked as executing and will remain there. If I right click here on my SQL Server name, reports, standard reports, all blocking transactions, I'll be able to see it. Let's wait for it to load. So here it is. It's transaction ID, some properties, the blocking SQL statement. Let me open like this. There it is. Full transaction. This is what is blocked. So let me close it. And now On the second transaction, I'm going to produce a deadlock because there was already a block in here, and on the second transaction, I'm going to update a host country set name to Brazil, just like I did here. So SQL Server will understand that the second transaction, SPID 55, caused the mutual blocking, and it will be terminated. Take a look. Execute, and only a few seconds later, this guy here is terminated. There it is. So transaction process ID 55 was deadlocked on lock resources with another process and has been chosen as a deadlock victim. So I'm going to roll back this guy here. Oops, it's already rolled back. I'm going to roll back this one. Now, let me close these two guys and open a block check. I'm going to run a script to produce some more blockings so you can see the display using transact SQL instead of the interface. There it is. So look at how simple is this code. So I'm using the legacy table, not even using DMVs. I could be using, but that is just to give you a quick method of retrieving blocking data. So the current speed, who is blocking it, last wait time, the database login time, and program name that is used. In this case, I'm using a DOS prompt to access the SQL Server using SQL CMD. So it says here, program name, SQL CMD, and the command that is being ran by each transaction and my login. So there's a delete statement and one update statement. 56 being blocked by 57, and 57 it's being blocked by 55. If I go here again in reports, all blocking transactions, it will be there as well. So there are many ways to check for blockings. There's the blocking statement. I put a wait for delay 2 minutes. This was intentional to produce the block, the waiting in the blocks. If I expand the transaction, these are the details of who is blocking who. So you can either check this by interface, you can schedule a job in SQL Server Agent to capture blocking data, you can run scripts to verify for blockings like every 5 minutes or every minute, every hour. You can configure alerts to fire up whenever a blocking transaction remains active for a certain period you define. So these are just some methods I wanted to show you on how we can check for blockings and the difference between a blocked process and a deadlock.